In 2006, NASA launched the New Horizons probe to explore Pluto and its moons. The spacecraft traveled for 9 years and crossed the mark of 50 astronomical units from Earth, which is more than 7.5 billion kilometers. In July 2015, New Horizons made a flyby of Pluto and took the first close-up pictures of the dwarf planet. The stunning images of Pluto showed something unusual going on there. What was it that grabbed the attention of the scientists? Hello and welcome to Planetarium, where we unravel the space chronicles beyond Earth. Join us as we explore the fascinating discoveries made by NASA's New Horizons probe, which traveled more than 7.5 billion kilometers to reach Pluto and take the first close-up pictures of the distant world. In today's video, we'll discuss Pluto, the farthest planet from the Sun and the only dwarf planet in our solar system. Even though Pluto is no longer classified as a planet, it is still an exciting target for exploration. Discovered by American astronomer Clyde Tombaugh in 1930, Pluto was once considered the 9th planet in our solar system, orbiting the Sun just like the other planets. However, in the 1990s, discovering several similarly sized objects in the Kuiper Belt, a region beyond Neptune containing numerous icy bodies, prompted a reassessment of Pluto's planetary status. This led to its reclassification as a dwarf planet by the International Astronomical Union in 2006. The images by New Horizons revealed a fascinating world with a heart-shaped feature and many bumpy volcanoes raised to different heights. The suspicion of such volcanic activity on Pluto had existed for some time due to its location in the Kuiper Belt. This discovery has strengthened the possibility of the existence of an ocean on Pluto, further increasing likelihood of life. According to planetary scientist and author Kelsey Singer, who spoke to Rebecca Son of Space, no other region on Pluto shares the same characteristics as this particular area, making it entirely unique in the entire solar system. Pluto is an icy, frigid planet consisting of frozen nitrogen and carbon monoxide ice. Kelsey Singer explained to Ashley Strickland of CNN that the icy material that formed the structures was most likely a slushy mixture of ice and water, or a toothpaste-like consistency, as it flowed out of the volcanic vent and onto the planet's surface. The surface of Pluto is too cold to sustain liquid water for an extended period. The flow of material from the cryovolcanic activity created the large domes and uneven terrain that is present throughout this region. What's even more surprising is that there were no impact craters from asteroids or meteors nearby, and no evidence of plate tectonics activity that plays a crucial role in mountain formation on Earth. Typically, such craters leave noticeable scars on the terrain, leading researchers to believe that cryovolcanic activity took place in the area roughly 100 to 200 million years ago, covering up the previous impact craters. The newfound activity of these ice volcanoes implies the possibility of future eruptions. According to Kelsey Singer, who spoke to CNN, these cryovolcanoes might behave like volcanoes on Earth, remaining dormant for some time before becoming active again. Furthermore, the absence of evidence of plate tectonics has raised questions about the creation of mountains on Pluto's surface. Mountains are typically formed through tectonic activity, which is not observed on the planet. Based on various findings, it is suggested that the surface of Pluto was created by a geologic disturbance, similar to a volcanic eruption, which occurred within the past 2 billion years. Among the many bumpy structures on Pluto's surface, 2 towering peaks, Wright Mons and Piccard Mons, have puzzled astronomers and space scientists for years. These features are unusual and require further study. Wright Mons is around 150 kilometers wide, bulges out up to nearly 5 kilometers above the surface, and has a central depression that is almost 50 kilometers across. On the other hand, Piccard Mons rises to nearly 7 kilometers and has a width of around 225 kilometers. Even though Pluto's diameter is just 1/6 of the Earth's, this volcano's total volume is similar to that of Hawaii's Mauna Loa, one of the enormous volcanoes on our planet. These gigantic surface features sit at the southwest edge of the Sputnik Planitia ice sheet, which is the lighter region on the left of the famous heart-shaped feature on Pluto, and was first spotted when the New Horizons spacecraft flew past the planet in July 2015. The Sputnik Planitia ice sheet, which is roughly 1,000 kilometers wide, appears to be an ancient basin which folds and rises on the surface, creating a wrinkled appearance on the otherwise smooth ice terrain. The region also contains numerous volcanic domes that often merge to form larger ones, but their status as active or dormant is yet to be determined by scientists. Pluto is an icy world with a heart of frozen nitrogen and carbon monoxide ices. The surface was formed after a geologic disturbance, possibly a volcanic eruption, recently within the past 2 billion years. Even though 2 billion years seems to be a pretty long time considering the cosmic timescale, it's not that long and can be classified as a recent event. In addition, the surface of material in this region is primarily water ice and not nitrogen or methane ice, as usually found in other younger parts of the planetary surface, which further solidifies the possibility of cryovolcanic activity. But how can Pluto have volcanoes if it is so cold and far from the sun? The answer lies in cryovolcanism. Cryovolcanism is a type of volcanic activity that involves the eruption of volatile substances such as water, ammonia, and methane instead of molten rock. Cryovolcanism is prevalent on icy bodies in the outer solar system, such as Saturn's moon, Enceladus, and Jupiter's moon, Europa. These moons are known to contain subsurface oceans of liquid water which are kept warm by tidal heating caused by the gravitational pull of their parent planet. Enceladus has shown evidence of regular cryovolcanism by spewing icy material out into space and replenishing one of Saturn's rings. Pluto's cryovolcanism is likely fueled by excess heat from its formation trapped within it, most likely in a deep water ocean beneath its icy crust. If cryovolcanism is still active on Pluto, it will strengthen the possibility of finding a liquid ocean there, and, who knows, maybe life too. The existence of a subsurface ocean on Pluto would make it the only dwarf planet with a subsurface ocean in our solar system. The possibility of finding life on Pluto is still remote, but the discovery of cryovolcanism opens up exciting opportunities for the search for life beyond Earth. So, does Pluto host life? The discovery of cryovolcanic activity and hidden oceans on Pluto has led to the question of whether the planet could support life. While the surface temperature of Pluto is around -240 degrees Celsius, many experts consider it too cold to sustain life. However, the hidden oceans beneath the icy crust could provide a stable environment with warmth and organic molecules delivered by comets or asteroids, potentially supporting life. Additionally, the volcanic activity on the planet could provide essential nutrients for life to flourish. While the existence of a hidden ocean on Pluto remains unconfirmed, and even if it is found, the likelihood of life on the planet is low. Nevertheless, the discovery of cryovolcanism on Pluto has paved the way for further research and exploration. With time, we may uncover additional mysteries on the planet, including hidden oceans or cryovolcanoes. What are your thoughts on whether Pluto could potentially support life? And what kind of life forms do you think could exist on the planet? Feel free to share your opinions in the comments section. If you enjoyed this video, make sure you like it and subscribe to our channel for more episodes, where we unravel more fascinating mysteries in faraway lands beyond Earth. Stay tuned.